Welcome to MET 200, the Manufacturing Processes and Material. This is Dr. Hamid Isazadeh. In this lecture, we will speak about casting processes. In the previous lecture, we talked about the sand casting, and this lecture will cover other casting processes. This lecture will look at this part of chapter 11. Other expandable mold processes are shell molding, expanded polystyrene process, and investment casting. The first process is shell molding. The shell molding is a casting process in which the mold is a thin shell of sand, and the sand is held together by thermosetting resin. And it has several steps. The first step is a metal pattern is heated and placed over a box, as you see in this picture. So this is the metal pattern, and then we have a sand on the bottom, and it's mixed with the thermosetting resin. Then the box is inverted, like picture 2. It's inverted so that the sand and resin fall onto the hot pattern, and this causes a layer of mixture to cure on the surface of the pattern, metal pattern. So the mixture is partially cured. It's not it's not ready yet. In the next step, box is a reposition. So the uncured particle will drop, as you see in the picture 3. The next step, the sand shell is heated in an oven for several minutes. It depends on the how thick the shell is, and all the sand and the thermoset resin will be cured, and the shell mold is removed from the pattern in the picture 5, as you see here. And then we have two halves of the shell mold which are assembled together. They will be supported by sand around it. This part, this area, all of them are sand. They will support the shell. And then we pour the hot metal into the mold. Then we can take the part out once the metal is solidified. Shell molding, like other casting processes, has its own advantages and disadvantages. Here are some of them. First, let's look at the advantages. We have a smoother cavity surface, which permits easier flow of the molten metal, and it gives you a better surface finish. And the next one is a good dimensional accuracy. So it requires, once the part is done, the as casted process requires, less machining. And next point is mold collapsibility minimizes cracks in the casting, and it can be mechanized for mass production. The problem limitation with this casting process is that it's more expensive for in terms of the metal pattern. So pattern in the sand casting was wooden, so it's less expensive. But here, because we are using metal pattern, it's going to be more expensive. And here another problem with the shell molding is that for a small quantity, it's not justified to go with this process. So if you want to make more number, for example, 1,000 or 20,000 of the parts, then it makes sense to go with the shell molding. The next process is the expanded polystyrene process. And this casting process uses a mold of sand packed around the polystyrene foam pattern, and that foam pattern will vaporize when we pour the molten metal into the mold. And it has other names as like a lost foam process, lost pattern process, evaporative foam process, and a full mold process. The polystyrene foam pattern has sprue riser gating system already inside, and also it has the internal cores if it needed. The good thing about the process is that the mold doesn't need to be opened into cope and drag sections. Here are the steps in the expanded polystyrene process. In the first picture, as you see, um, we have a refractory compound that we sprayed over the polystyrene foam pattern. And the next step, the foam pattern is placed in mold box. Then we have sand around that pattern, which will be packed compact around the pattern. And the next step, we have molten metal, which is poured into the mold, because the mold that foam pattern has a low melting temperature, a low uh, it will vaporize immediately as soon as the molten metal is poured into that mold, and then it will make a space for the molten metal. Um, then it's going to be similar to casting process. The metal is going to be solidified. Then we remove the parts from the box. Then we have the final part. Again, there are some advantages and disadvantages for this process. The advantages is that the pattern, we don't need to remove it from the mold. It can stay in the mold because it's going to be vaporized when the molten metal is poured into the mold, right? um, then it's simple in terms of making the mold. And a good thing about that, it doesn't need two half of the a mold and the drag and cope. So that is a big advantages. The disadvantage is that we need a pattern for every single casting. So it requires some justification in terms of cost. If you want to make one sample, two sample, probably it's not cost effective. If you want to make a batch production, then this process might be a good fit. This process has many application. Um, one of the application is the mass production of a car, car engine. So here we have one example. As you see, this is the engine block made of aluminum with this process, expanded polystyrene casting process. Next process is investment casting, also known as lost wax process. We have a pattern made of wax, and it's going to be coated with the refractory material to make a mold. Then the wax is going to be melted away before pouring the molten metal. The process has a very high accuracy, and it can make a very complex geometry, complex pattern, and these are good benefits of this process. Here we have the 7 steps for this process for investment casting. First, we have to create wax pattern in figure 1 right here. Then these patterns can be attached to a sprue to form a pattern tree. This is a pattern tree, has several patterns connected to each other, and then the pattern tree is coated with thin layer of refractory material here. So it's going to be dipped into the refractory material, which is in liquid form. Then we have a full mold that is going to be taken out. Then the mold is held in the inverted position and heated until all the wax is going to be melted, and then we allow it to drip out from that cavity. So all the wax is going to be taken out. So we don't have the wax or the mold, the wax pattern inside this mold anymore. Like this picture. All wax is gone now. Then we have the mold ready for the casting process. The molten metal is poured into the mold here, and then it solidifies. When the process, the metal is solidified to certain temperature, the mold is going to be broken away, and then you can separate it from the sprue. So these are the final part. Here we have one piece that was made by investment casting. This is a compressor stator with almost 100 separate airfoils inside. And as you see, the quality, the surface finish of this part is very high, comparing with the other casting processes that we talked so far, like sand casting and shell molding. This process, like other casting processes, has its own advantages and disadvantages. The first advantage is that you can make parts with the great complexity, and if you make part with a good complexity, it means that the need for post-processing can be reduced, so the cost goes down if you can make part with one process. You will have a good surface finish with this process. This is another good thing about investment casting. And as you know, we use wax for the to create mold. So the wax is melted, but we can reuse the wax for several times. This process is called the net shape process. Normally we don't have machining because we have a good surface finish, good accuracy. Disadvantages are you need to go through several steps to make the mold. So this is not advantage. This is one limitation. It takes some time to make the part, to make the mold ready, and it is expensive process. It's again similar to previous process, shell molding, this is not recommended if you want to make one part, two part, less than 10 part. You have to make, you should um, use the process for at least 1,000 parts. So far we talked about expandable mold casting, but there is another casting process called permanent mold casting. And the problem with the expandable mold casting is that we need a model for every single casting. So you cannot make one part, one uh, mold to use it multiple times. If you want to use the mold for multiple times, then you have to switch to a permanent mold casting process. Um, this process, this permanent mold, has several category. It has die casting. It has centrifugal, casting process. Permanent mold process uses a metal mold constructed of two sections designed for easy and precise opening and closing. We use a steel or cast iron for the mold, and if we want to cast alloys with lower melting temperature. If we want to cast a steel, then we have to use refractory material, because steel has a high melting temperature. This slide shows the several steps in the permanent mold casting. Here we have the mold is preheated first, and then it's coated with the lubrication or some material for heat dissipation. In the next step, we can put cores if it requires. The cores are inserted, and then the mold is closed. In step 3, molten metal is poured into the mold. Then it will solidify. The last step, the mold is open. The part is going to be ejected from this part, and the part is done. It's ready to use. Permanent mold casting has some limitation and some benefits. The first benefit is that it has a good dimensional control, and it gives you very good surface finish. And during the process, we have a rapid solidification, during the cooling process, because of the mold. You have a metal mold, so it can transfer the heat faster than you have a finer grain. We discussed before, if you have a faster cooling rate, then the part is going to end up having a finer grain. If you have a finer grain, the material is going to be stronger. And the next point is that due to high mold cost, the process is best for high volume production and can be automated accordingly. Here we have some of the parts that are designed and produced by this process. Pump bodies, certain casting for aircraft and missiles. We have we can cast aluminum, magnesium, copper-based alloy, and cast iron. And the limitation of this process is that you can work with metals that has a lower melting point, and they should have a simpler part geometry. In the expandable casting process, we didn't have that limitation, and because here we have to open the mold, right? So that makes it difficult to make a complex geometry with this feature that we have to open. And then the mold is expensive. It does not make sense to make permanent mold casting for just 5-10 samples. Again, the number of samples has to be high enough, like 1,000 samples. One of the permanent mold casting is called die casting. Die casting, in die casting, we have molten metal um, injected into the mold cavity under high pressure. So we have some pressure that makes it completely different from other casting processes, and the pressure is going to maintain during solidification. Then once the part is solidified, we can remove the part from the mold. And the mold in this casting operation is called die, and the whole process name is die casting. And in die casting, you can make parts like this picture, as you see, piston, cylinder, pump, as you see here, and with a high accuracy. In this picture, we have a die casting machine. The die casting machine is designed to hold and accurately close two mold halves and keep them closed while the liquid metal is forced into the cavity. And they have two types. One is a hot chamber machine, and the other one is cold chamber machine. In the hot chamber die casting, we have a metal that is melted in a container, and a piston injects the liquid metal under high pressure into the die. And the production rate can be 500 per hour, or about 500. And the application is limited to low melting point metal, and some of the casting metal are zinc, tin, magnesium. And here is the process, as you see in this picture. And this picture A, the one we have this die, which is closed, and the plunger is gonna push downward, and it will create a flow of molten metal into the chamber, like this picture. So this plunger actually create high pressure. Because of that pressure, the molten metal will be under pressure inside the die. Then when the metal is solidified, plunger is withdrawn, die is open, then the casting is going to be ejected from the die. The next process is cold chamber die casting, where we have a molten metal poured in an unheated chamber from external melting container, and the piston injects the metal under high pressure into the die casting. We still have a high production, but not usually as fast as the hot chamber. We can work with the aluminum, brass, magnesium, but the advantages of the hot chamber process over the cold chamber is that we can work with the low melting material, because we have a container which is heated. So this material, which has a very low temperature, will stay in liquid state. Here we have 3 steps for the cold chamber cold chamber die casting process. As you see, the die is closed and the ram is withdrawn to all the way to the right. The molten metal is poured into the chamber. Then ram forces metal into the left to flow the liquid toward the die, and then it will keep that pressure. So the pressure is going to be maintained. Then the metal is going to solidify. Ram is withdrawn in this process. In this step 3, die is open, and then we have the part ejected from the die. The die casting actually has a mold, as you know. The mold can be made of tool steel or molded steel or maraging steel. All of them are very strong material. And also, if we want to use refractory material, we can use tungsten or molybdenum when we want to make steel or cast iron part. And another consideration in the die casting is that we need ejector pins, which are required to remove parts from die when the die is open. And we need lubricant. The lubricant must be sprayed onto the cavity surface to prevent sticking. And here we have one example, one part made of with the die casting processes. And a note about the maraging steel that I mentioned above. Maraging steel is martensitic steel, and it's known for its superior strength and toughness without losing ductility. Here are some disadvantages and benefit of die casting. Die casting is economical for large production quantity. It gives you good accuracy, surface finish. You can make a very thin section, such as the previous picture I showed you, and you have a rapid cooling process during solidification that gives you a small grain size and good strength for the part. And the limitation is that it is limited to low melting point material, and you need consider some simple geometry because we want to remove the part from the die so that the part cannot have a complex geometry. The next process is centrifugal casting, and the centrifugal casting is a family of casting process where we have a mold and it is rotated at high speed, so it is centrifugal force distributes the molten metal to outer region of the die cavity. And we have true centrifugal casting. We can have semi-centrifugal casting. The last one is the centrifuge casting process. In this slide we have a true centrifugal casting process where the molten metal, as you see here, is poured into the rotating mold. So the mold is this one. It's a rotating because we have a drive roller here. This is a free roller. This is the drive roller. So it creates a rotation for the mold. And the part is actually the molten metal is poured into this mold. Because of that, centrifugal action we have for the mold, the material is going to be distributed and stay in outer region, so we will have a tubular part. It is possible to create other shape like octagonal, hexagonal with this process. The next process is centrifugal casting, where the centrifugal force is used to produce solid casting rather than tubular parts. The mold uses riser as in the center to supply um, the feed metal as in this part. Next point about this process is that density of metal in this process is higher in the outer section, comparing with the center part, because material is going to be pushed away, so staying in the outer region. This process is used to make wheels, and pulleys. The last casting process is centrifuge casting, where we have a mold designed with part cavity located away from the axis of the rotation. Axis of rotation is this. No, sorry. This is the axis of rotation, and we have part cavity located this part and this part, and the molten metal is going to be poured into the mold, and it's, because of this centrifuge force, this liquid will be distributed toward this cavity, and this process is used for a smaller part, and the symmetry of the part is not required like other centrifugal casting processes.